Imagine you want to do a research about a new drug. Let's call this drug, for example, drug A for a group of people who have psoriasis. Psoriasis is a skin disorder. And then we make actually a research question that what is the effect of the drug A on psoriasis? And we can also say that our research hypothesis is drug A improved the psoriasis. This is what we want to find out. This is what's the aim for using of this drug. And to find out the answer, we can divide a group of the patients with psoriasis as a sample into two different groups, and we do it by the randomized selection. When we randomize them, we give a group, one of the groups drug A, and the second group will get the placebo, a kind of fake drug that has no effect. And a health advisor is going to evaluate this condition, and these people don't know that if they are getting drug A or placebo. The group that get the placebo will be the control group in this case. And then the health advisor that's going to evaluate them also evaluate at the beginning, and he also doesn't know that which person get which drug. Is it drug or is it placebo? And after 3 months trial, he do the evaluation one more time without knowing that this person had the drug or placebo. This is why we can call this kind of a study a double blinded controlled randomized controlled trial, or double blinded RCT. And when we do such a research as a randomized controlled trial, you see that the independent variable is the drug that we are using here for a dependent variable, which is the disease is psoriasis. Well, in the part that we describe this research, we have a descriptive statistic. We can explain it by the variables with the, for example, number of patients, the percentage of them, and so and so. But we still didn't answer the question about research hypothesis that drug A improved the psoriasis, and we need in this case to do a hypothesis testing. In reality, the majority of statistical analysis are based on the comparison, and the numerical value for comparison of interest, we call it the effect. We can formulate two different statements regarding the hypothesis. First, a null hypothesis when the effect is zero, and null hypothesis actually is the negation of the research hypothesis. And also we can have alternative hypothesis which says the effect is not zero, and we say that the drug A will improve psoriasis. And if we want to test it, and the zero effect, as I said, means there is no difference between placebo and drug A, we can use the p-value. P-value is the probability of the null hypothesis. And by p-value, we accept or reject the null hypothesis. We calculate the p-value, and based on this calculation, if it's the over 0.05, then we accept the null hypothesis, and when it's below the 0.05, like here, less than 0.05, then in this case we reject the null hypothesis when we accept the alternative hypothesis, and we say the drug A can improve the psoriasis, for example. In some studies, the cutoff point level is 0.01, as you see here, and they need more precision and use this value.